Hey everyone, this is our lesson on electrical circuits. So by the end of this lesson, you should be able to explain simple series and parallel direct current circuits in terms of Ohm's law, which we looked at in the previous lesson. So first, let's just make sure we remember what a circuit is and kind of understand what the goal of this lesson is. So an electrical circuit consists of some source of energy, usually a battery, a load of resistance, wires, and a switch. So the source of energy can be a battery, a photocell, a thermocoupler, I have a space there, and electric generator at a power plant. So those are just some basic examples. Usually the ones you guys would deal with on a regular basis, that would be a battery. The load would be the device that uses the electricity. So it could be a light bulb, it could be a buzzer. In this GIF, obviously, that would be the light bulb here. The switch is what opens and closes the circuit, which allows the energy to flow through the entire system. And circuits must be closed for electricity to travel through it. So open means there's a hole in the system, in the circuit somewhere. Closed means it's a closed circuit. So now let's talk about series circuits. So these particularly have a current that flows only through one path, like it cannot flow in multiple directions. And because of that, we have some issues, with disconnections. So if there is a disconnection in a series circuit, then the electrons can no longer flow. So when one thing doesn't work, the whole thing doesn't work. And the current is the same in every part of the circuit itself. The potential difference can change throughout the circuit, but the biggest thing to remember about series circuits are that if one part doesn't work, the whole thing doesn't work. And the best example about this used to be, they've definitely upgraded over the past 10 or 15 years or 20 years, were Christmas tree lights. So if one bulb used to go out, the whole strand would go out. So now we also have parallel circuits, which allows your current to flow in separate branches on that circuit. You can have two or more branches for current to flow through. So as you can see in this GIF, we have three different branches that the current can flow. And when you disconnect one branch, it does not affect the others. More current flows through the path of least resistance, and the potential difference is the same in each branch. So each branch is getting equal amount of that voltage. Whereas in a series circuit, the more like light bulbs you would have, the less voltage you would have as it keeps going. So like if you have three, the first bulb would get the most voltage, the second would get medium, and the third would get the least. Here, they're all going to get the same voltage because it splits through the entire circuit. So then again, if one branch is open or there's a disconnection, it does not affect the other branches. And a good example of this would be like a headlight or a tail light, because if one of them goes out, the other one still works. If they were on a series circuit, then if one went out, the other would go out, and that'd be super dangerous. So now that we understand these circuits a little bit, we can talk some about electrical power. And this is defined as the rate that electrical energy is converted into some other form of energy. There are different appliances, in your house that use energy at different rates, as well as appliances, outside of the home. This is measured in watts because it is still power, so it still has a watts unit. And it's calculated as current times the voltage. So let's look at this example problem. It says the current flowing through a lamp is 2.5 amperes. That's your current, your I. The lamp is connected to a battery having a potential difference of 12 volts. What is the power delivered to the lamp? So we know this information given here, and we know that our calculation is P is equal to I times V. So we're going to do 2.5 amperes times 12 volts, and that's going to come out to 30 watts. So another way to look at this unit is ampere times volt is equal to a watt. So now this is worded a little bit long. Make sure you write down the important values and units. But I'm going to cut my video off, and you go ahead and pause this video so that you can try this example.